Hello everyone, welcome back to my channel. I'm Vishwat Ramesh and today in this video I'm going to be talking about classification of hydroelectric power plants. So let's get started. So what is a hydroelectric power? Hydroelectric power is a renewable energy source that leverages the energy of falling or flowing water to generate electricity. This form of renewable energy is highly valued for its reliability and efficiency, making it a widely used source of power globally. So, what is its importance? It is a clean energy. Hydroelectric power plants do not produce greenhouse gas emissions, contributing to a cleaner environment. Reliable power. Hydroelectric power plants can provide consistent and predictable power output, making them ideal for baseload power generation. Water storage. Reservoir hydroelectric power plants provide a secondary benefit of water storage, which can be used for irrigation, flood control, and recreation. Economic benefits. Hydroelectric power plants can create jobs and boost local economies through construction, operation, and maintenance. So, the classification. So, the first is based on their head. The head of hydroelectric power plants refers to the vertical distance between the water source and the turbine. This factor significantly influences the power output and the type of turbine used. High-head plants. These plants utilize a head higher than 300 meters, allowing for high pressure and power generation. They are commonly found in mountainous regions with steep slopes. Medium head plants. With a head ranging from 30 to 300 meters, these plants offer a balance between power output and construction costs. They are suitable for a wider range of geographical locations. Low head plants. These plants operate with a head less than 30 meters, requiring large water flow to compensate for the low pressure. They are often found in flat or gently sloped terrain. So, based on the storage capacity, hydroelectric power plants can be classified based on their ability to store water, which determines their power output and operational flexibility. Reservoir storage plant. These plants utilize large reservoirs to store water, enabling them to regulate power output and provide a consistent flow of electricity even during periods of low water availability. Run-off river plants. These plants rely on the natural flow of water in a river, lacking storage capabilities. They generate power only when water is available and their output can fluctuate based on seasonal changes. So, based on the purpose. Hydroelectric power plants can serve various purposes, each requiring a different design and operating strategy. So, the base load plants. Designed to provide a constant supply of power, often operating at full capacity, they are ideal for meeting consistent energy demands. Peaking plants. Primarily used to meet peak electricity demand during specific times of the day or year, these plants can quickly adjust their output to meet fluctuations in demand. Pumped storage plants. These plants utilize excess power during low demand periods to pump water uphill, storing it for later release to generate power during high demand periods. So they're based on their size. Hydroelectric power plants are categorized based on the generating capacity, which is the amount of electricity that they produce. The large hydropower plants. These plants have a capacity greater than 100 megawatts, providing substantial power output for large cities or industrial areas. Small hydropower plants. These plants generate between 1 and 100 megawatts, serving smaller communities or industries. Mini hydropower plants. These plants have a capacity ranging from 100 kilowatts to 1 megawatts, typically supplying power to isolated villages or farms. Micro hydropower plants. These plants generate less than 100 kilowatts, often used for residential or individual power needs. So, based on the turbine type. The type of turbine used in a hydroelectric power plant is determined by the head and flow rate of water, significantly impacting its efficiency and performance. Impulse turbines. These turbines are designed for high head applications and utilize the full force of the water jet to drive the blades, making them efficient for high pressure systems. Reaction turbines. These turbines operate with both pressure and velocity changes in the water flow, making them suitable for both high and low head applications. So, they're based on the operations of hydroelectric power plants. Hydroelectric power plants can operate in various modes, each with unique characteristics and applications. Conventional hydroelectric plants. These plants operate using the natural flow of water, generating electricity based on available water resources. Pumped storage hydroelectric plants. These plants utilize excess energy to pump water uphill, storing it for later release to generate power during peak demand periods. Underground hydroelectric plants. These plants are constructed underground, minimizing visual impact and often utilizing natural underground reservoirs. So, based on the construction type. Hydroelectric power plants utilize diverse construction methods, each tailored to specific geographical and hydrological conditions. Dam-based plants. These plants utilize a dam to create a reservoir, storing water for later release to drive turbines. Diversion plants. These plants divert water from a river using a wire, directing it through a channel to power turbines. Pump storage plants. These plants involve two reservoirs at different elevations using pumps to move water uphill for later release to generate power. So the base of the location. The location of a hydroelectric power plant is crucial, influencing its design, the construction and operational characteristics. So in the mountainous regions. Thank you everyone for watching this video. I hope you are now clear with the basics understanding of different classification of hydroelectric power plants. So please support me by liking and sharing this video. Thank you.